we have got the general idea about the periodic table, and we came to know about the different groups name along with the elements present in it and periods as well. Okay, now today we are going to see a very important thing. Say for example, if an element is given, then how to identify in which group and in which period it belongs. Okay, say for example, it is very simple to understand. It is very simple to understand. Say for example, sodium is given. Sodium, whose atomic number is 11. So first what you need to do is you'll write its electronic configuration. Since atomic number is 11, number of proton is 11 and number of electron will also be 11. So when you write down electronic configuration, it will be 281. That means in the first orbit we'll have 2, in the second 8, and last one 1, KLM. Okay, now in this the last electron, that means the last outermost cell, whatever number is there, that will be a group number. Say for example, in this we have got 1 electron in the outermost, so group 1 will be for this, so sodium belongs to group 1. And for period we have to count the number of cells or orbit. First cell, second cell, third cell. So how many periods? So how many cells or orbits? 3. So it belongs to third period. Understood? So the last electron in the outermost will represent the group number, and the number of cells or orbit represents the period. Similarly, if you go for calcium, atomic number 20, so when you write down the electronic configuration, we write it as 2882. So in the last we can see that we have got 2 electrons, that means it belongs to group 2. And how many cells? 1, 2, 3, 4. So it will belong to fourth period. Okay, so this is very important part. Now we have to understand the term periodicity. What does periodicity means? Okay, so periodicity means the properties that reappear at regular intervals. Okay, the properties that appears at regular interval are called periodic properties, and the phenomenon is known as periodicity of elements. Now what is the reason for periodicity? That means what caused the elements to be have the similar chemical properties and physical properties. The main cause of periodicity is the presence of same number of electron in the last orbit. Okay, so the cause of periodicity is the recurrence of similar electronic configuration, that is having the same number of electrons in the outermost orbit. Say for example, if you consider group 17, that is halogen, we have got fluorine, chlorine, bromine, iodine, okay, all these elements. Now in group 17, if you write down the electronic configuration of this element, you'll find 7 electrons in the outermost. That means they have got the same electrons, and because of that same electron in the outermost, they also similar chemical properties. Okay, they also similar chemical properties. So we can conclude that periodicity is due to the same number of electrons in the outermost orbit of different elements. Next we discussed about cells that we call orbits and valency. Okay, what are they? Cells or orbits. As we know, electrons revolve around the nucleus in certain definite circular path, that we call it as orbits or cells. Okay, now number of cells. So what will happen if you go down the group in a periodic table and when you move across the period? So when you move down a group in the periodic table, what will happen? The number of cells or orbit increases, as we know. Say for example, we have considered group 17 once again to understand this thing. So fluorine, chlorine, bromine, iodine and astatine. So over here when you write down the electronic configuration, the first will be 27, then for chlorine 287, like that it goes on. Okay, now if you see, when you moved down the group in the periodic table, the number of cells are increasing, that the number of orbits are increasing. Got it? So that is down a group. When you move across the period, what will happen? The number of cells remains the same. That means the orbit remains the same, only the electrons get added. Okay, next term we need to understand valency. Valency means it is the combining capacity of an element. Okay, it is equal to the number of electrons an atom that can donate or accept or share. Now Now what will happen to the valency when you go down the group and we move across the period? This is important. On moving down a group, the number of electrons in the outermost cell remains the same as we have seen before. That was the cause for periodicity. Okay, so therefore the valency in a group also remains the same. So therefore the group valency will remain the same. Say for example, group 1 elements, alkali metals, they have got 1 electron in the outermost, so they are similar. Similarly, group 2 elements, all of them have got 2 electrons in the outermost, so their valency will be 2. Similarly, group 17, their valency is 1 because they need only 1 electron to be stable. Okay, similarly, when you move in a period, across the period, the number of electrons in the valence cell increases from left to right. Okay, increases from left to right.